Okay, this video is going to go into the basics of graphing exponential versus log functions. So let's go ahead and get started. This first one, you're just graphing exponentials. So you need to know what exponentials look like. They take this shape. And right here, by default, is a 0, 1 point. Because if it's like 2 to the x or 10 to the x, it doesn't matter. If you input 0 right here, it's like 2 to the 0, which has a y value of 1. So that's why that is. Also, exponential equations have horizontal asymptotes. And so by default, this horizontal asymptote is y equals 0. But if you do any sort of transformations, that will change. So that's what the default equation looks like. So let's look at some of these. I'll come back to this part, but for now, let's just try to graph some of these ourselves. 1/2 to the x. All right, when your value here is less than 1, let's try that again. Less than 1. It's not like this. It's not exponential growth. Instead, it's exponential decay. And so instead of starting low and going high, it starts high and goes low. Now it still has a horizontal asymptote, and it still has this point here of 0, 1. It just takes a slightly different shape. And so if you think about this, the domain is all reals. And the range, the highest it can go is positive infinity. The lowest it can go is 0. So the range is 0 to positive infinity. And this 0 has a parentheses because it will never actually hit 0. Okay, look at this next one. 2 to the x minus 1. This is a horizontal shift to the right 1. So instead of normally being at 0, 1, now it's going to be at 1, 1. So it would still take the normal, this shape, because your base is bigger than 1, so it is exponential growth. It's just now this point is at 1, 1. And so if you're looking for this y-intercept, basically it's going to be where you have an x value of 0. So it's like 2 to the 0 minus 1, which is 2 to the negative 1, which is 1/2. So this intercept is at 0, 1/2. The domain's all reals and the range is still 0 to infinity. So no need to really think about that too much. Okay, now they start to get a little more complicated when you do something like this. 4 to the x minus 3 plus 3. That's a shift to the right 3 and up 3. So on all of these so far, we've had a horizontal asymptote of y equals 0. Well, now that horizontal asymptote is going to change. It's going to become y equals 3. And so this graph would still take that same shape. And if you're looking for this y-intercept, the easiest way to do it is just plug in 0 for x. So that's like 4 to the 0 minus 3, and then plus 3. So that's like 4 to the negative 3, which is 1 over 64 plus 3. So you could just call it 3 and 1 over 64 for that intercept. And so the domain's all reals. The range, though, the lowest it goes on this one now is 3. Highest it goes to infinity still. So e to the x, it looks just like this one. I'm going to skip that one. All e is, it basically just like a number. It's just like 2.72. It's just the natural base. I don't really know how the easiest way that I just think about e is it's 2.72. And that way I just never get confused. So like this one, this is 2.72 to the negative x plus 4 to me. That's how I see it. So this negative x, though, this is going to reflect it across the y-axis. So instead of it looking like this, well, now it's going to switch sides. Like this part's going to go over here. Anyways, it'll look something along the lines of this. Still has that asymptote of y equals 0. It's just in this particular example, the asymptote changes to be y equals 4. And the graph just reflected across the y-axis. So it looks something like this. If you wanted to get this y-intercept, you would plug in 0 for x. So you would get e to the 0, which is 1. And then plus that 4 would make 5. So this intercept's at 0, comma 5, like that. And the range, the lowest it goes is 4. So, all right, and then the last one, you have -4 to the x plus 2 plus 1. Well, the -4 reflects it across the x-axis this time. So ignore this one. If you look back at the original, if you flip that across the x-axis, it would look something like this. With instead of 0, 1 now, it would be 0, -1, like that. All right, so that's the shape that this graph is going to take. Now it is going to move left 2 and up 1. So this up 1 is where I usually start. That's your asymptote, y equals 1. And then it's going to look something like this. And if you wanted this y-intercept, you would plug in 0 for x, so you'd get -4 to the 2 plus 1. And so based on order of operations, I know you want to call this 16, but it's not, it's -16. And so this would be -15. So I have an intercept at 0, comma, -15 here. And then if you wanted to solve for the x-intercept, you would plug in a y value of 0. And so we're not going to get into how to solve that just quite yet. But if you're wondering, it is -2. All right. Now we move on to where they compare them. So they first want you to graph 2 to the x, which would look something like this. All right, done. And then they want you to graph y equals x, which would look like this. Done. And then they want the reflection of 2 to the x. So they want to reflect it across this y equals x. So it would look like this. All right, sorry about that. That's what it would actually look like. Okay. Now, the reason they wanted you to do that is because the blue line is log. It's the inverse of the exponential. So that's the general shape that these log functions are going to take. Now, I will say, if you're going to try to do this page, you really need to know these 4 things. So give me a second, and I'll draw it out for you. Okay, there you go. You need these 4 things kind of going on in your head. Just the base, what they look like when there's reflections everywhere. So now let's look at what they want me to do here, like number 9. I'm just going to do real rough graphs for this. So, and I'm going to do them right here. Okay, number 9. It's a normal ln is basically just log base e. So it takes these shapes. So it's a positive log. So it's going to look something like this. And that x plus 4 just means it shifted to the left 4. So it still has this general shape. It's just since it went left 4, Now it's got an x-intercept at -3, 0. So that's this first one, number 9. And by the way, these log functions, they have vertical asymptotes. So like by default, this vertical asymptote, it's at x equals 0. All right, let's look at number 10. It's a ln negative x. So what this means is they've reflected it across the y-axis, this axis. They reflect it across that. So instead of going like this, well, now it just goes like this. All right, so number 10 would look something like this with an x-intercept here of -1, 0. That one's pretty easy. All right, number 11. Now they threw a negative out in front as well as a vertical stretch, but I don't really care that much about that vertical stretch. I care about that negative out in front, because what that's going to do is it's going to reflect it across the x-axis. So instead of it looking like this, well, now it's going to reflect across the x-axis. So it's going to go down like this. All right. And so this one would just take this shape right here, just like this. Okay, number 12. It's a negative negative. Now, in my opinion, these are the most confusing. And the reason is because there's a reflection across the x-axis and across the y-axis. So that's why I like to have this one drawn out, ready to go. That way I don't get confused when I know I have to draw it. So this one's going to have, it's going to look exactly like this right here. You're going to have a reflection from the parent across the x-axis and across the y-axis. So this one's already graphed right there. All right, number 13. 13 is kind of tricky. When I looked at it, I saw this 3 minus x part as negative x plus 3. So you want to say shift left 3, but in reality, it's a shift right 3. And it's a shift right 3 off of the negative x function, which is this one right here. So it takes this function and just shifts it to the right 3. So it looks something like this. So that x-intercept was at -1, 0. Well, now it's at 2, 0 because I went right 3. And there is definitely a asymptote here. And that asymptote is at x equals 3. All right, and then the last one, I'm not going to go too much into detail about it, but it basically is a reflection across the x-axis. So it's going to take this shape, and then it also moves left 6. To get that, you set that x over 2 plus 3, set it equal to 0 and solve it. You'll get 6, all right? Or you'll get -6, which means to the left 6. So it goes left 6 and then down 4 as well. And it has a vertical stretch. But basically all that means is it takes this shape, left 6. And so if you're wondering about the asymptote, it's right here at x equals -6, since you went left 6. So that's how you draw these functions. I don't really feel like getting into matching, but in order to do that matching, you're really just going to want to have this right here drawn. It'll make your life so much easier because you'll know what the general shape of it looks like. And then you just kind of got to ask yourself, well, did I move up, down, left, or right? And then you just match it up. Which brings us to this, the piecewise functions. Now, piecewise are notorious for being kind of difficult, but let's just go ahead and take it one at a time. 21. Okay, there's two pieces, one less than 0 and one greater than 0. So let's do the less than 0 first. This less than 0 piece takes my ln negative x parent function shape. So let me see if I can just copy this. Give me 1 second. All right, there we go. So this ln negative x it looks like this guy right here. And so you basically trace it the exact same. The only difference is you're going to stop at 0. Well, that's easy because you never actually hit an x value of 0. So this left side just looks like this. Now, we also have to do the right side. It just takes the general shape, which also never hits 0. And so this first one would look just like this. If you're wondering about domain, well, it's everything except for 0, right? It's everything except for x equals 0 there. So you could write that either as x cannot be 0, or you could write it as two different pieces, like -infinity to 0, union with 0 to infinity. The range is all reals because it goes down forever, up forever. And then in terms of intercepts, this guy's at -1, 0, and this guy's at +1, 0. So that's number 21. All right, now 22. It's more of the same, except this one, the break's at -1, not 0. So like you'll go to do the first guy here, which takes this shape. The thing is, you have to stop at -1. Well, that also happens to be where that x-intercept is. So it looks just like this, and it stops at that -1, and it has a closed circle there because of the or equal to sign. So it looks like this. Now, the second one is a negative. These are my least favorite. And he starts at -1. So he starts at this intercept, and it's everything to the right of it. So it's this section of line right here. So it just kind of like he had an open circle and then did just like this. That's what this graph would look like. So in terms of the domain, it's not going to cross 0. There's a vertical asymptote here. So the domain is everything from -infinity to 0. The range, well, the lowest it goes is 0, and it hits it on that intercept. And the highest it goes is +infinity. And that intercept, it is a closed dot, not from red, but from green. And then, so that intercept's at -1, 0. Okay. Next up, 23. Let's do the first one. The break's going to happen at 1. So over here now. Okay. We're having technical difficulties. That's okay. All right. So the first one is a negative len, which is going to take this shape right here. And so it's going to look something like this. But remember, I have to stop at 1. So like usually I would have gone the whole way, but I have to stop at that intercept of 1, and it's an open dot there. So that's the first section of line. Now the second section of line is just regular old len, which takes this shape, but it starts at 1. So it starts at this x-intercept and goes like this. And it has the or equal to, so it lets us fill in this hole right here. And so now if you're talking about the domain of this line, well, there's an asymptote here at x equals 0. So the domain furthest left it can go is 0, and it'll never hit it. And then it goes right forever. So +infinity. And the range, the lowest it went was that intercept of 1. Highest it goes is +infinity. And that x-intercept's at 1, 0. And the last one. All right. It's just regular old len from 0 to 1. So it takes this right here from 0 to 1. So it's really just this part right here. So it looks like this. And it's an open circle there. And there's a vertical asymptote here. All right, now the second section, it takes a negative len function. So this one right here. And it starts at 1. So it's really this section right here. So it looks like this. And it fills in the hole because it has the or equal to. So when you're talking about the domain of this, the domain, the furthest left it can go is 0. The furthest right is infinity. The range, the lowest that it goes is negative infinity. The highest it goes is that intercept, which has a y value of 0. And the intercept's at 1, 0. So, all right, that is the basics of graphing some exponentials and some logs. Again, I would have this right here kind of handy as you learn these. It'll just they can get so confusing if you can't just look at a picture of it and know instantly. So that's my advice. But anyways, hope this video helped.